area before temperature is increased. Therefore, this is the initial area. The length of this solid before there is increase in temperature, or I can also say there is some change in the length. Consequently, there has to be change in area. Before there is expansion, initial length is proportional to L0. Delta T is directly proportional to initial length, increase in temperature. Hello students, continuing my discussion on thermal properties. In my today's class, I will refer and understand one of the consequences of heat, how matter realms itself under the subjection of heat. A very beautiful concept, what I call as thermal expansion. So in my today's class, we will be understanding the concept of thermal expansion, and with reference to thermal expansion, we will understand the different types of expansions. The so-called linear expansion, superficial expansion, cubical expansion, and so on. So my first attempt today is to understand what is thermal expansion. So we have all studied that this word thermal refers to heat. Therefore, I can also call it to be heat expansion, thermal expansion. Now, what is this heat expansion? Expand. Yen expansion andre? Expand agodandre eno? Increase in something. Very good. So we say the increase in the dimensions of a body. Very clinical word here, dimensions. The increase in the dimensions of a body due to the increase in temperature is called thermal expansion. See, very beautiful. The textual definition says the increase in the dimensions of a body. Why the dimensions of the body is getting changed? It is due to the increase in temperature. Hagadre, what does this word dimension categorically refer to? Dimensions change agate, dimensions increase agate. What do I mean by that? I mean to say either the change in the length of a body or change in the area of a body or the volume of the body. These are the dimensions I am referring to, students. Change in dimensions andre maybe the change in length, change in area, change in volume, and that is what I call change in dimensions. And why dimensions of a body change? Due to the increase in temperature. When I say increase in temperature, it means supply of heat. Increase in temperature is always the result of supply of heat. And that is why we say it is thermal expansion or heat expansion. So students, the increase or the change in the dimensions of a body as a result of increase in temperature is called thermal expansion. Now, depending on the change in dimension, depending on what feature of the solid is changing, which dimension is getting changed, thermal expansion is of three types. The first one is called linear expansion, where there is an increase in length. Linear, straight line expansion. Superficial expansion, where there is increase in area. And volume expansion, where there is increase in volume. Therefore, students, as I told, depending on which dimension is getting changed, we classify thermal expansion into three types. Change in the length, which is called linear expansion. Change in the area, which is called superficial expansion. Change in the volume, which is called volume, or which is also called as cubical expansion. Now, let us go to the first type of expansion, what we call as linear expansion. As I've already mentioned, linear in terms of length. So the increase in the length of a solid, increase in the length of a solid due to the increase in temperature is what we call linear expansion. So please to understand, linear L refers to increase in length. So the increase in the length of a solid. Why? Due to the increase in its temperature is called linear expansion. Linear, nenpitkolli. Linear andre with respect to length anta artha. Now, L naught, if you observe the diagram, is the initial length of the solid. So I am calling this L naught as the initial length. ಏನಿದು initial length ಅಂದ್ರೆ? Initial length means length of the solid before there is increase in temperature. Only when temperature is increased, length can change. Nenpitkolli. So L naught is the length of the solid before there is increase in temperature, or I can also say before there is expansion. Initial length ant karidvi. And I say delta L is the increase in the length when the temperature is increased by delta T. So what are the factors I look for here? L naught, initial length of the solid before expansion has happened, before temperature has increased. Delta L, increase in the length of the solid. Delta, the word delta refers to some change. The moment I use the word delta, it means change. Delta L, change in the length. Here I am talking about increase in the length. And delta T is what is called increase in temperature. Now, my first point here is to understand what does delta L depend upon. What are the factors on which the increase in length depends upon? Good. I say the first factor, delta L, is directly proportional to L naught. What is L naught? Initial length of the rod. Alva? If the initial length itself is very small, increase in length will also be small. Initially itself, if the rod has large length, after expansion, increase in length is also more. So delta L is directly proportional to L naught, initial length of the rod, and it is also proportional to delta T, which is change in temperature. Andre, you increase the temperature by 5 degrees Celsius ankolana. Small increase in temperature, increase in length is also small. Increase the temperature by 10 degrees Celsius, slightly more, which means the increase in length is also more. Increase the temperature by 50 degrees Celsius, again drastic increase in temperature, change in length is also more. Therefore we say delta L, that is increase in length, is proportional to L naught. Delta T is directly proportional to initial length, increase in temperature. Now this proportionality has to be eliminated. How? First chapter ಹೇಳ್ಕೊಟ್ಟಿದ್ದೀನಿ. If proportionality has to be eliminated, a constant has to be introduced. And I call this constant as alpha, where, very important, it's a constant what we call coefficient of linear expansion. ಈ ಟಾಪಿಕ್ ಮೇಲೆ ನಿಮ್ಮ ಎಂಟ್ರೆನ್ಸ್ ಎಕ್ಸಾಮ್ಸ್ ಅಲ್ಲಿ ಕ್ವೆಶ್ಚನ್ಸ್ ಕೇಳ್ತಾರೆ. ಸೊ ಬಿ ಕೇರ್ಫುಲ್. Alpha is called coefficient of linear expansion. So wherever you have linear expansion, wherever you have change in length, it is associated with the term alpha. Their alpha is called coefficient of linear expansion. Now, what is alpha indicating? When I say coefficient of linear expansion, what do I mean by that? For which now I use unitary condition. I need to define alpha. So I say, if L0 is 1 meter, if the initial length of the rod is 1 meter, and change in temperature is 1 Kelvin, delta T is 1 Kelvin, then alpha becomes equal to delta L. Is it not? L0 na 1 meter ant madidini. Delta T 1 Kelvin aitu, change in temperature. Then delta L is nothing but alpha. So what is alpha indicating? Delta L. Alpha is a coefficient which gives me the change in length of a solid whose original length was 1 meter. When the temperature is increased by 1 Kelvin. Andre, in simplest terms to understand, alpha indicates how much has the change in the length occurred, or how much of change in the length has taken place when the temperature is increased by 1 Kelvin, whose original length was 1 meter. So alpha is indicating the change in length. Change in length of a solid whose initial length was 1 meter when the temperature was increased by 1 Kelvin. Good. On the same basis now, I will try to understand superficial expansion, which is nothing but increase in area. Change in area. My dear students, I can conclude saying that the moment there is some change in the length, consequently there has to be change in area. Superficial, or what is also called aerial expansion. Therefore we say the increase in the area. Remember, superficial expansion related to area. Change in the area of a solid due to increase in temperature. That is what is called area expansion or superficial expansion. Length change ಆದಾಗ ಅದನ್ನ linear expansion ಅಂತ ಕರೆದ್ವಿ. Due to the increase in temperature, if the area of the solid is changing, that is what is called superficial or area expansion. Now, A naught refers to the initial area of the solid. Initial area, as we did initial length, area before expansion, area before temperature is increased. Therefore, this is the initial area. And delta T or delta A is the increase in the area when the temperature is increased by delta T. Now, as we did before, delta A, which is the increase in area, is directly proportional to A naught. If the initial area itself is small, after expansion, again the area is small. If the initial area itself is large, after expansion, area occurred is large. Therefore, delta A proportional to A naught, and again it is proportional to delta T. Small increase in temperature will cause small increase in area. Large increase in temperature will cause large increase in area. Therefore, removing the proportionality, I introduce a constant called beta, where beta is the coefficient of area expansion. Beta always related with area expansion. Alpha linear expansion, beta area expansion. ದಯವಿಟ್ಟು ನೆನಪಿಟ್ಕೊಳ್ಳಿ, alpha is the coefficient of linear expansion, beta coefficient of area expansion. Now, if A naught is 1 meter square, I am initializing the conditions, boundary conditions. Delta T, increase in temperature is 1 Kelvin. Then beta is delta A. So what is beta giving me? It is the increase in the area of the solid. Very clearly, if you see, beta is delta A, something associated with area. So it is the increase in the area of a solid whose initial area was 1 meter square. when the temperature was increased by 1 Kelvin. So we say beta coefficient of superficial or aerial expansion just indicates how much of area has increased, how much of area has changed when the temperature of the solid was increased by 1 Kelvin, whose initial area was 1 meter square. Now, going to the next type of expansion, volume expansion. This is what I want you all to take up as an assignment. Exactly as we learnt linear and superficial expansion, I would like you all to assess cubical expansion, where we say gamma is the coefficient of cubical or volume expansion. Now, this is important. How do I relate alpha, beta and gamma? Coefficient of linear, superficial and aerial expansion. Alpha is to beta is to gamma is 1:2:3. Always remember this ratio. Alpha is to beta is to gamma is 1:2:3, which means alpha is 2 times beta and alpha is 3 times gamma. If the length changes by 1 unit, area changes by 2 units. Length changes by 1 unit, volume changes by 3 units. So my dear students, in today's discussion, we have clearly understood the consequences of thermal expansion. Whenever you increase the temperature of a body, it gets expanded. Its dimension changes. If length increases, you called it to be linear expansion. Area increases, superficial expansion. Volume increases, cubical expansion. Alpha for linear, beta for area, gamma for volume. They are related as 1:2:3. Again, in my next session, I will take over to other heat related concepts of matter. Until then, revise, practice, be thorough. Thank you.